Hi, Joshua Kylan here. I thought I'd do a video. I'm sitting down, and please excuse the noise in the background. Someone is welding down here at Makerspace. I thought I would go over what I made at LSC. Just a heads up, I have my camera plugged in and I got an LED light behind me. So sorry for the weird angle. It is just what it is. Let's begin. This is a drill sharpening guide. That was the first project I made. Yes, I did get a beard trim. Yeah, so this is for sharpening drill bits. This is a adjustable parallel, because you can get various heights, and not my finest work, but it's pretty sloppy, but it did pass. By the way, this was made on a manual mill. This is a tap handle. These are the handles. If you look in here, that's the keeper. These threads were done on a tool room lathe, which is a CNC conversational lathe. Then we had to match the taper right here, knurl it, and do that rounded corner on the end. We had to do 2 of them. This one is bent, so this is the tap body. Basically, the main portion of this was done on a CNC mini mill. They did the profile, this profile, and left 2 square bosses on the end here and bored a small hole through the center. And what we had to do was bore it out to the correct size, and also turn the ends to be round, and also drill and tap the center. I did do a grind shaft. I think that's at home, but basically we had to, in between centers, we had to turn a bunch of different diameters and a bunch of different grooves on one piece of steel without having it bend, because those grooves are pretty deep, and if you force it too much, you can actually bend the piece in the lathe, and that is not fun. Trust me, I've seen a couple people do it quite a few times. That's it for the manual stuff that I have right now. I did a conversational mill, which is a hybrid in between of a manual milling machine and a CNC, all enclosed, but you can actually work it and program it right at the controller. The first thing we did was make this piece of aluminum. You had outside contour, a pocket, and 2 slots, then a can drilling cycle. So this is what I think was the first project. It's been a couple of years it's been a while since I've been down there. The second one is this coaster. Basically, you got 2 pockets. You got a square pocket, then a circle, then you got 8 holes around the edge. Basically, face mill it, and then you engrave the initials on the back. And let's just say, according to how Randy, who was my teacher or instructor, that's too deep, but I actually do like it. I think miscalculated the depth, so, and it turned out pretty good. Sorry, I've had a slight cough for the last couple days. The next machine I moved on to was a mill turn. Basically, it's a combination of a milling machine and a lathe. Of course, CNC. And basically, actually, which one was it that was too thick? Oh, this one is what we had to do. And this is a profile, all handwritten on Notepad using G's. Basically, I can actually show you on my laptop on what the code is. You got turns, and then basically what it is, it faced the front, turned it down, then milled this, and then parted it off. Well, actually, it did this radius on the back, then parted it off. Actually, what you have to do, sorry if you can't see that, but basically what I had to do a slight depth cut right there, back up, move over, and do the profile, and continue on to it being parted off. I'm tired. And this one is a lot thicker. And what I'm thinking is have this as a hood, a grill emblem for one of my tractors. So the next thing that we did on the mill turn was made chess pieces. And sorry, I have to cheat, and basically I can't remember the names of it. But these are your rooks. And yes, this was done on a mill turn, and we had to manually write it. So, yeah, I believe these are the knights. We had to make 2 each. Let's just say, doing this, that's at an angle. I don't know if you can see that, but see that angle? That was done on the mill turn. And let's just say that was quite an ordeal to handwrite. So we have two of them each. And I think was a mini mill. Of course, these aren't in order. I can't forget what order I did the machines. And we made, this is a caliper depth stop. This goes on the end of the caliper, and it gives you a nice flat surface to mount your caliper in here. Sorry. I got up at 7:30. I normally sleep until 9. So that was done. We also made on the mini mill. Actually, I think this was on a different mill. We made the bodies for these. So, and we actually did some production work to make more of these for the intro class. Actually, technically the advanced turning class. Then on, I believe the next project was on a 5-axis machine. It's basically a standard 3-axis mill with 2 rotary tables on it. That's a triangle, that's a triangle, that's a square, and that's a pentagon, or no, sexagon, or however you say it. And then we actually made these threads. And that's basically, that is basically 4 straight line cuts, but with a twist. Basically feed straight in while you rotate your axis. And that makes the threads. And that goes on this nut. It should. Of course, there's quite a bit of rust and everything's not. And the goal was to make it so it did. I think, yeah, so you get the idea. So we made that. Each person had a different length that they had to deal with. Then I made this. This is a cube within a cube within a cube within a cube. There's 4 cubes. And my plan for this is, even though right here there's a small ding in the aluminum, that's because I dropped it on accident here. I think this is like the 4th or 5th time, or probably 3rd or 4th time I made this video. What my plan is for this is probably mill a good portion of this off, drill and tap it, and have this as my hood ornament for my MTD 990 diesel build I want to do. So basically between this one, a front emblem, and then a hood ornament, so it'll be decked out. So that's my plan with those. Then, by the way, this one I had to handwrite the code. This name plaque, not really, because if you look out the end, it's curved. I did this in CAD-CAM, or Mastercam, or it's basically CAD is computer-aided design, CAM is computer-aided manufacturing. And I think there was about 30,000 lines of code for this particular job. Basically, while it was making the pass, it would rotate this back and forth, back and forth, back and forth. And it made my name, Josh K. And my plan is to hopefully one day drill and tap both sides, or drill both sides and mount it. I probably might mill off a good portion of the back, but I probably won't. So this was my last project on the 5th axis machine. The final project, or actually the second to final machine I worked on, was a horizontal mill with a pallet changer. Basically there are 4 different machine surfaces that you can do on the pallet, then it rotates for another 5. Or no, another 4. And this is what I made. This is called a Geneva wheel. And each one of these parts, besides this shaft, was done on that mill. And this, Lake Superior College, was engraved on the machine. But this project I didn't have to write the hand code for. I just had to put in all the offsets for it. So, but someone on this one, there was a bunch of screw ups because someone decided to change the program. And let's just say, right in there, there's a broken tap. This one too, there's another broken tap. So let's just say this one, the tapping cycle was totally wrong. So Max, who was my instructor for the CNC portion, actually fixed it. So that was all said and done. And the last machine I worked on was a Swiss lathe. And this is what we made. A flashlight. I don't have the guts for it, but I can get the guts for it. You have LSE engraved on the one side, then Josh on the other. Basically, we had to modify the program to put our initials on, or name on it. And that groove on the end is for O-ring. And the programs were already done, but we had to, again, put in the offsets. And this is the one I made. And this was one that was scrap that I kept. Basically, I found 2 ends for it and made a little container. I also kept another front and another back. I'll be right back. There is one little neat thing that I forgot to grab for that came off this twist. Sorry, I'm back. Is when it went to do the drilling cycle, and we were just practicing making. This is one of the little pieces I cut off, and I got it just perfect. Where if you see, there's a little concave and a hole in the center, which will make a nice reflector. Actually, that was the second to last machine, or technically the third to last. I had 2 EDM machines. EDM stands for electrode discharge machining. In this case, these 2 pieces were made with the wire type. It basically is a little wire that runs through the part, and it basically sparks the material out. I also operated a EDM drill, and you have to use that when you have to drill tap out. And this is a square. Technically it's a rectangle cube. Whatever. I'm getting all tired. And this is a squircle. It goes from technically a square to a circle. And if I remember right, we had to draw this out. Same thing with this. So I operated an EDM. I believe the last machine I operated was a sinker type EDM. It uses a actual sinker die, and that's what made this. It was a helical, basically it was this but made out of carbon, and it basically sunk down and twisted at the same time, and that's how you got this. And if you look at the finish, you actually can see those sparks that it caused. The EDM process is primarily used in the medical industry. You might be saying, why am I not at a CNC machine right now? A, I am done with school, and B, the first place I worked it was so damn busy, and they didn't really give me a good review. Basically, they fired me for not having enough production requirement. How in the world can I know what the production requirement is when you don't give me an actual number? And they let me go after 5 weeks. That is why I was unemployed for 2 months. And now I'm working up at APA. They make wire harnesses for Cirrus. And they also make Fraser, which is a doctor's office tool. I can't go any deeper than that. That's all it is. Right now I am at the wire prep station, where what we do is I primarily operate a laser ROJ. ROJ stands for remove outer jacket. It lasers a line in the jacket, cutting it. Then we pull the jacket off, do the braid operation, then we crimp whatever wires need to be crimped. So that's basically why I have a passion for metal and the manual mill. That is partially why I am where I am today. So that is why I'm not making a living doing CNC, is because it was so hectic at that place. So yeah, so that's why I am where I am. Thanks for watching. Please comment, rate, and subscribe. And thanks for sticking in for the whole video. See you in the next one. Bye.